Additional Mathematics classroom. Today we will do question paper 2021 May-June paper 21. Okay, the first question here. Write the expression x square minus 6x plus 1 in the form x plus a whole square plus b. So this form is called the completed square form. Completed square form. Alright, so what is the step? First step, take the coefficient of the x term, which is 6 here, minus 6, divided by 2, we get minus 3. Then step 2, you don't have to write this step 1 and 2. Just for illustration I am writing here. So step 2, write this expression given, x square, write the second term, minus 6x. Then whatever answer we got in the first step, add its square. Then subtract its square and then write the last term, which is plus 1. Now step 3, if you observe the first 3 terms here, it is nothing but x minus 3 whole square. What was a minus b whole square in algebra? It was a square plus b square minus 2 into a into b, which is this term. Alright, so we got one bracket whole square. Now we will simplify the rest of the constants here. So it is minus 3 whole square is plus 9 and plus 1. So the last step is x minus 3 whole square minus 8. So this is the completed square form of this expression. Now comparing it with this expression here, we identify a to be minus 3 and b to be minus 8. That is the answer for 1A. Now going to 1B. Hence write down the coordinates of the minimum point. Okay, the equation is same. Y is equal to x square minus 6x plus 1, which is also equal to x minus 3 whole square minus 8. We have seen this in the previous step. Now we have to write the minimum point coordinates. What is the minimum point? Minimum point is the stationary point where the curve goes from the least value to a higher value. For example, if we plot this graph, we can see it is a quadratic equation. So the graph will be something like this. So this point here is called vertex. It is also called mean point. Why it is called mean point? Because at this stage, the graph reaches the least value possible. When we say graph reaches, we are talking about the y value. And then from there you can see the y value increases. So this is called the vertex or the mean point. So we have to find this mean point coordinates. Now since we have it in completed square form, we can get the mean point coordinates straight away from here. So the general equation of a quadratic expression, its completed square form is like this: x minus h whole square plus k. If it was like this, then the mean point coordinates are h, k. Right? So if you have minus inside the bracket and a plus outside the bracket, then straight away h and k are the coordinates of this graph. Now this is not straight away clear if we have it in this form, but it is very clear if you have it in the completed square form. So from here we can identify h to be 3 and k to be minus 8. So this is the coordinates of the midpoint. So that is the answer for 1B. Let's go to question number 2. Variables x and y are such that when ln y is plotted against ln x, a straight line graph passing through the points 6, 5, 8, 9 is obtained, where b and q are integers. It is given that when ln y is plotted against ln x. Observe here on the y-axis we are plotting straight away ln y, not only y. Similarly on x-axis ln x. So we get a straight line which is passing through 6, 5 and 8, 9. This much is given. We have to show we have to get an expression for y basically. So now, what is the equation of a straight line? It is y is equal to mx plus c. Now in place of y we have ln y. So we will substitute ln y equal to m into, in the x-axis we have ln x plus c. So the equation of this straight line is ready if we get m and c. Let's say how to get m. For m we have been given two coordinates and hence we can use this formula y2 minus y1 divided by x2 minus x1. So 6 minus 9. So 5 minus 9 divided by 6 minus 8. So this gives us minus 4 over minus 2, which is plus 2. So m is ready as plus 2. So our equation becomes y ln y equal to 2 into ln x plus c. Now to find c, we can make use of the 2 points on the line given. We can use either this one or this one. Let us use this one. So 6 is the value of the x coordinate. In this case it is ln x. And 5 is the value of ln y. So for ln y, we substitute 5. Note here, you are not going to write ln 5. You are going to write 5 to substitute entire ln y equal to 2 into 6 plus c. So it is 5 equal to 12 plus c. Here we get c equal to negative 7. So our equation becomes ln y is equal to 2 ln x minus 7. Now we have got an expression in terms of ln y, but we want it in terms of only y. Alright, so we will use some logarithmic identities here. 2 ln x, we can write it as ln x square. Why? Ln x power n is n into ln x. So if you have any constant multiplied to an ln, we can raise this x by this power n. So now to combine these two terms ln x square and 7, let us write 7 in terms of ln, which is 7 into ln of e. Why? Ln of e to the base e is 1, right? So this one simplifies to ln x square minus, using the same identity here, it is ln e power 7, which is ln x square divided by e power 7. What is the identity we used here? Logarithmic, either ln or base 10. A by b, we can write it as ln a minus ln b. So ln a minus b, we can write it like this, which we are doing here. So ln y is equal to ln something in the bracket. Both ln's on both sides. So this clearly tells us y is equal to x square divided by e power 7, which we can write it as x square into e power minus 7. Because any number in the index form, you can change its position by just reversing its index sign. So we got an expression for y. Now comparing this with the given expression e power p x power q, we identify p is equal to negative 7 and q is equal to 2. So this is the answer for question number 2. Now going to question number 3a. Solve the inequality modulus 4x minus 1 greater than 9. Now what is the meaning of this modulus sign? It means we are taking only the magnitude of whatever is there inside this sign. So if we have modulus of 2, the value is 2. Modulus of minus 2, then also value is 2. So the modulus always gives us the positive value, even though the expression inside may have a negative value. So we will make use of this one. There are two methods to solve this. So I will explain you both methods. Let us look at first method. So 4x minus 1 is greater than 9, considering 4x minus 1 is positive. And minus of 4x minus 1, even if this expression was negative, then also the inequality holds. So we will solve these two inequalities to get two values for x. So 4x is greater than 9 plus 1, 10. X greater than 10 over 4. So x greater than 2.5. So opening the bracket, minus 4x plus 1 greater than 9, or minus 4x greater than 9 minus 1, 8. Now when we multiply both sides of the inequality by minus 1, we need to do this because we don't want the negative sign with x, so we multiply with minus 1. But we should remember, when we do that, the inequality will reverse. So we get positive 4x, but inequality reverses and we get negative 8. So x less than negative 2. So what is the solution for this one? It is x should be less than negative 2 and x must be greater than 2.5. So this is the answer for 3A. Same question we will solve with method 2. So we know that this expression can have a positive sign or a negative sign, right? But if we square this inequality on both sides, whether this side is positive or negative, it will convert to positive. So making use of that, we don't have to worry about the negative sign. So we will square on both sides. So what do we get? 4x minus 1 whole square is greater than 81. Squaring 9. So we will expand this with the algebraic identity a minus b whole square, which is a square plus b square minus 2ab. A square, 4x square plus b square minus 2 into a into b is greater than 81. Minus 8x minus 81 plus 1 minus 80 greater than 0. So we will simplify this by dividing by 8. 2x square minus x minus 10 is greater than 0. So you solve this quadratic equation, for quadratic expression, we get two factors, x minus 2.5 and x plus 2 is greater than 0. Now how do we decide which are the values of x for which the y value, this side is always y value, is greater than 0? The simple way to decide is to draw the graph. We know this graph is a quadratic equation, is a quadratic expression with the factors 2.5 and minus 2. So minus 2 is here, 2.5 is here. These are the x-intercepts. So the graph looks like this. So we can see that for this part of the graph, the value of y is negative. Whereas for the outside part of the graph, value of y is positive. Therefore, this expression must be greater than 0. That means we are looking for x values for which y is greater than 0. So the inequality that satisfies this y greater than 0 is x either must be less than 2.5, that is to the left. Sorry, x must be less than minus 2. So you can see here, from the value to the left side of this minus 2, y is positive. And it should be to the right side of 2.5, which is x greater than 2.5. Okay, so this is the same solution that we got with method 1. So check and see which method you find it easier and you can follow the same method. Let's go to 3b now. Solve the equation 2x minus 11 root x plus 12 equal to 0. So here also we have two methods to solve this. Let's do with method 1. Check which method is easier for you. You can follow that. So method 1, we will substitute y as root x, so that when we do y square, we get x. Now rewriting the equation, 2 into x is 1 square minus 11 root x is y plus 12 equal to 0. So use the formula y equal to minus b plus or minus square root of b square minus 4ac whole divided by 2a to solve this quadratic values for x. Which is, if you solve it with this formula, we get two values for y. So one is 4, or another value that you get is 1.5. Alright, so now we got the value of y, we can get the value of x. So y is 4, that means root x is 4, therefore x is 16 square. Root x is 1.5, x is squaring 2.25. So these are the two values that satisfy this equation. So this is the answer for 3b. Now let us solve the same equation in the second method. So here we will rearrange the equation to be like this. Take this term minus 11 root x to the other side. It becomes plus 11 root x, and club the other two terms together. Now we will square. Why we need to square? Because we want to get rid of the square root sign. So squaring on both sides, what do we get? 2x plus 12 whole square is equal to 11 root x whole square. Squaring this as a plus b whole square, we get a square plus b square plus 2 into a into b. 2 into 2x into 12, we get 48x equal to 11 square is 121, root x square is x. So we will rearrange this one now. 4x square, bring this 121x to the other side. Then we have this 48x, then this 12 square, which is 144, equal to 0. So we get a quadratic equation x. So minus 121 plus 48, we get minus 73x plus 144 equal to 0. So we got a quadratic equation straight in x. In the method 1, we got a quadratic equation in y. We got the value of y and then we converted it to x value. But here you will get x value straight away. So you solve this using the formula method or factorization method. You will find that x is equal to 16 or x is equal to 2.25 are the two values that we get for x, which is a solution for question 3b. Let's do question number 4. The graph of y equal to a plus 2 tan bx, where a and b are constants, passes through the point 0, minus 4 and has a period 480 degrees. Find the value of a and b. So first of all, we have a tan function here. So we know the period of tan is 180 degrees. Okay, so that means 180 divided by this b here has given us this new period, which is 480. So from here it follows that b is equal to, you move b here, 480 here, so it becomes 180 divided by 480, we get 3 over 8. So that is straight away the answer for b. Okay. Now to find the value of a, we will make use of this one point which the graph is passing through. That means when x is 0, y is minus 4. Let us substitute here. Y is minus 4 equal to a plus 2 tan bx. b is 3 over 8 into x is 0 from here. So which is a plus 2 tan 0. So it is a plus 2 into 0 is 0. So therefore a is equal to minus 4. So a is minus 4, b is equal to 3 over 8 is the answer for 4a. Solve 4b. The equation y after substituting a and b values looks like this. Now if we have to plot a simple function y is equal to tan x, where x is here and y is here, the graph would look like this. This is 0 degrees, this is 180 plus 180, this point is minus 180. The shape of the graph is like this, which repeats itself for every 180 degree intervals. That is why it is called the period of tan function. Now the shape, if you see, it becomes asymptotic with this x equal to 90 degrees. And it becomes asymptotic with x equal to minus 90 also. So this is how a simple y equal to tan x function would look like. Now we will see how this expression can be drawn. Now see here, the period is, for this given function, the period is 480, right? So we have to change this one to be 480. So this one is the exact midpoint, which is 240. Similarly, this here is minus 240 and this one is minus 480. Okay, so this would be the graph if the period was 480. Okay, now we took care of this part here. Now how do we take care of this 2 here? Okay, remember when x was 0, y value was -4, right? This was given. So that means when x is 0, y is -4, that means the y-intercept is -4. When y equal to tan x, when x is 0, y was also 0. So that was this point. But now this point has been moved to like this. So that means it must be cutting y-axis not at 0 but at -4. So we have to change the graph. So instead of that, so we have to change the graph now. So look carefully. How am I going to draw it? New graph will look like this. Here this point is -4. Alright. Now accordingly this 480 graph also will change. So how will it change? So at this period, at this 480 degree, it is going to be this shape. This shape repeats. And then it repeats like this. Okay, so this is how the graph of this given expression is. -4 says it is cutting y-axis at -4. Here we had just tan x, so it was cutting at 0. That is one difference. Second difference is the 480 degree period. So this is 240, this is 480. So instead of cutting it exactly on the x-axis, it cuts at y equal to -4 line. Okay, but now we have to show the graph from 0 to 480. So that means the negative parts we have to erase. So you are supposed to show only from 0 to 480. So the final graph is from here. So we don't want this again because it is beyond 480. So this will be the final graph. Okay, note clearly this point is 480. This here, which is asymptotic line, is at 240 degrees. Then this part and this part. So this is the final answer for question 4b. Let's go to question number 5. The curves y is equal to x square and y square is equal to 27x intersect at 0, 0 and at point A. Find the equation of the perpendicular bisector of the line OA. So let's draw a rough sketch of the graphs here. So y is equal to x square is this graph here. So this is y is equal to x square and y square is equal to 27x. So we get y is equal to root 27x. So if you plot this graph, it looks like this. So this is y is equal to root 27x. Now these two lines, these two graphs intersect at 2 points. One is at the origin, which is 0, 0, and another is this point here, which is A. So the question is, we have to find the equation of the perpendicular bisector of the line OA. So we draw a line OA here and then a perpendicular bisector. So we have to find the equation of this perpendicular bisector. So once you draw the rough sketch, let us write the steps. So the first step, we will find the coordinate of point A. So we know the point 0, 0. Now we know the point A. Once the 2 points, the coordinates are ready, the line OA, we can find the gradient. Then find gradient of line OA. So once the gradient of line OA is ready, we can find gradient of perpendicular bisector, because we have a relation m1 into m2 equal to -1. That is, the m1 is the gradient of line OA, m2 is the gradient of the perpendicular bisector. So their product is always -1. So using that relation, we will find the gradient of the perpendicular bisector, and then we will find midpoint of line OA. That is exactly this point here, the midpoint. Why do we need the midpoint? because to find the equation of any line, we need one point on the line and the gradient of that line. So the gradient of the perpendicular bisector we found here in step 3. The midpoint of line OA is also a point on the perpendicular bisector. Bisector means it passes through the midpoint of OA. So this midpoint is a point on the bisector. So now we have the gradient of the perpendicular bisector. We have one point on the perpendicular bisector. So the last step will be to find the equation of perpendicular bisector. Alright, so whenever such a question comes, carve out your steps like this, divide it, and then do it one at a time. Alright, let's start with the first step. So first step is to find the coordinates of A. For that, we will equate the two equations because that is a point of intersection of the two curves. So y is equal to x square, y square is equal to 27x. So let us get y square from here. So squaring this equation, I get y square is equal to x power 4. Now we equate y square is x power 4 equal to here y square is 27x. So x power 4 minus 27x is 0. So x as the factor, common factor, x cube minus 27 is 0. So from here it follows that x is 0 or x cube is, let us write the step in between, x cube minus 27 is 0. So x cube is 27, x is 3. So we have got two values for x. So this x equal to 0 is the 0, 0 origin, the one point of intersection. Remember, this is given already. So this is the x coordinate of point A. So we have to find the y coordinate. So we can use any one of the equation. So let me use the first one. Y is equal to x square, which is 3 square, and that is 9. So the coordinates of point A are 3, 9. So our first step is done. Now going to the second step, we have 2 points, the point O and point A, the point of intersections. So second step is to find the gradient of line OA. So the formula is y2 minus y1 divided by x2 minus x1. So it is 0 minus 9, difference in y coordinates divided by difference in x coordinates. So this is minus 9 divided by minus 3. The gradient of line OA is 3. So this is step 2. Step 3, gradient of the perpendicular bisector. If we call the gradient of OA as m1 and gradient of OA, the perpendicular bisector is m2, the relation m1 into m2 is always minus 1. So we will substitute here m1 3, m2 as it is equal to minus 1, which gives us m2 is equal to minus 1 over 3. So the third step is over. We found the gradient of the perpendicular bisector, which is minus 1 over 3. Now the fourth step, we will find the midpoint of OA. Midpoint of OA, which is a point on the perpendicular bisector also. Bisector also is equal to, so it is the x coordinates average 0 plus 3 divided by 2. Remember, we are finding the midpoint of O and A. So their x coordinates add and divide by 2. Add y coordinates, divide by 2. So it is 3 by 2 is 1.5, 9 by 2 is 4.5. So this is the midpoint, that is one point on the perpendicular bisector. We have the gradient of the perpendicular bisector. So we are ready for the last step now. So the equation of perpendicular bisector now is y is equal to mx. M is the gradient, which is minus 1 over 3 x plus c. The point 1.5, 4.5 is on this bisector, which is the midpoint of OA. So we will substitute here 4.5 is equal to minus 1 over 3, the value of x here, which is 1.5 plus c. So this is minus 3 1 times 3 0.5. So it is minus 0.5 plus c. So c is equal to 4.5 plus 0.5, we get 5. Therefore, the final answer, perpendicular bisector equation is y equal to minus 1 over 3 x, or we can write minus x over 3 plus 5. So this is the answer for question number 5. Going to question number 6. Variables x and y are such that they are related by the equation y equal to e power x by 2 plus x into cos 2x, where x is in radians. Use differentiation to find the approximate change in y as x increases from 1 to 1 plus h, where h is small. So what we need to find, read the question again and be clear. We have to find the approximate change in y. That means we have to find delta y, the change in y. Okay. So change in y when the small change in x is h. So the delta x is h. So delta y by delta x, which is, so we have to find delta y by delta x, which is delta y by h, because the change in x is 1 to 1 plus h. So the absolute change is x. The change is h. So we have to find delta y by h. This is nothing but dy by dx when x is equal to 1, which is its original value. So x value is changing from 1 to 1 plus h. So the change is only h, which is very small. So delta y by delta x, which is delta y by the change in x is h, is dy by dx when x is equal to 1. So we have to find dy by dx expression first and then substitute x equal to 1. Then our answer is ready. Alright, let's do that now. So dy by dx is equal to differentiation of e power x by 2. We get exactly e power x by 2 multiplied by the differentiation of x by 2 is half. That is the constant alone. Dx by dx is 1. Plus here we have to apply the product rule. What is the product rule? If u is x and v is cos 2x. Why it is a product rule? Because both the terms x and cos 2x are functions of x. So that is why we have to use the product rule. If this was like 2 into cos 2x, where 2 is a constant, we don't need the product rule, remember. Alright, so d by dx of u into v is u into dv by dx plus v into du by dx. So we will apply it here. U into u is x. dv by dx, differentiation of cos 2x is minus sin 2x into 2 plus keep v as it is, which is cos 2x into differentiation of x with respect to x is 1. So let us simplify this further. E power x by 2 divided by 2. Then 2 into minus sin 2x into 2, we get minus 2x sin 2x, then plus cos 2x. So when x is plus 1, the dy by dx is equal to e power 1 over 2 divided by 2 minus 2 into 1 is 2 sin 2x, 2 into 1 is 2 plus cos 2x is 2. So put your calculators in radians mode and evaluate this expression. So you will find that the answer will be minus 1.41. So that is the answer for question number 6. Thank you for being there in my classroom today. If you need any clarifications on any of the questions that we solved today, you may contact me on my channel in Discord. For more details, please refer to the description box below. Thank you.